Hello and welcome to another video. Today we are focusing on privilege escalation on Linux systems. I'll be showing you some hypothetical examples of how users can expand their access within these systems. And to do this, I will use a ROM called Common Linux Priv Esc from 𝒕𝒉𝒊𝒔. So before we move on, I want to emphasize that the techniques and tools we are discussing are for educational purposes and should only be used legally, such as in ethical hacking or security testing with proper authorization. It's crucial to respect privacy and follow the law, so make sure you are using this information responsibly. With that important note out of the way, without further ado, let's get to it. So, what's privilege escalation? Privilege escalation is a term used in cybersecurity to describe when someone gains access to more permissions or abilities on a computer or network than they are supposed to have. Now, imagine that you have a key that only lets you into the lobby of a building, but you found a way to make it open an office on the top floor. That's similar to what privilege escalation does in a computer system. Now, there are two main types of privilege escalation, the vertical and the horizontal. Vertical privilege escalation happens when someone gets higher level permissions than they should. For example, a regular user might find a way to gain administrator rights, which lets them do just about anything he wants on the system, like viewing confidential information or changing key settings. Horizontal privilege escalation, on the other hand, occurs when a user expands his access at the same level of security. This means he can do things other users at his level can do, but specifically those things he shouldn't be able to do, like accessing another user's private files. Now, the first thing that we can do when trying to escalate our privileges is gather information, and for that we have a tool called LinEnum. So I will show you this tool. LinEnum is basically a script that automates the task of gathering information to help attackers understand how they might elevate their privileges on a target system. When deployed, LinEnum truly scans the Linux system it's executed on. It collects a broad range of data, including system configurations, user details, security settings, and much more. The tool is designed to identify common security weaknesses such as misconfigured files, excessive permissions, and exploitable scheduled tasks. These vulnerabilities could potentially allow an attacker to escalate his privileges, gaining more control over the system. However, in order to use this tool, we need to upload it on the target's machine. And we have two ways to do this. So by a Python web server and by copying the raw file and paste it into a new file on the target's machine. However, before we move on, I will just download our file and let me just see if the file is here. Okay, and here we have our file on our terminal, and we need to do something before we move on, and that is SSH into the target's machine. So SSH, the username, in this case it's user3 and our IP. But we need to use our clipboard, otherwise we can't paste it on our terminal, okay? Now we can. So we click enter, we insert yes, and we insert our password. In this case is password, as you can see here. And as you can see, we are now user 3. This is our remote machine, okay? I will open a new tab. So this is our local machine, and this is our remote machine. As I was telling you, we have two ways to upload the file into the target's machine. So the first one is by using a Python web server, and the second one is by copying the raw file and paste it into a new file on the target's machine. Now, you can use the first way when you are able to transport the file. And if you are using the first way, you just need to insert the commands python 3-m http 𝒕𝒉𝒊� on your local machine, okay? This command will serve files from, in this case, your directory. In other words, with this command you will serve the file LinEnum from your directory to the target's machine. Then, on the target's machine, so on the user 3's machine, you can use the command wget, then your local IP, and to know your local IP, so remember that this is our local machine. To know our local IP, you can use if config, and here you have it. Okay, so you copy this, I will exit this tab, and you paste it here, okay? Now, if you click enter, you will see that this is the port that you need to insert here. So, you insert colon and then the port 8000. Now, you insert /forwards and the name of the file. And the name of the file is LinEnum.sh. So you click enter. So as you can see, our file was downloaded, and if you do ls-l, you will see that we have here our file, and this file isn't executable. So we need to make this file executable. And to do that, we insert the command chmod plus x, and then the name of the file, in this case, is linenum.sh. You click enter, and if you run the command ls-l, you will see that now our file is executable, okay? Now, in the case that you are unable to wget the LinEnum file into the target's machine, you can do the second way. The second way is by copying our raw file, and then on the target's machine you create a new file with the command touch, and the name of the file, let's see, linenum.sh. You click enter, and if you do ls, you will see that now we have a new file called linenum.sh. However, this file is empty, and we need to paste our raw file into this new file, and we can use nano to do that. LinEnum, we click enter, and in the clipboard so we paste it here, and as you can see, we have now our LinEnum file here, okay? So this is the second way that you have. You save it, and you need to make this file executable as well. And for that, you use the same command that you used before, so this one here, okay? But I will remove the new file because we don't need it. And now we have our LinEnum file on our target's machine. Our file is now executable, and we can now run this file. And to do that, we use the command // and then the name of our file. However, I will save the output into another file. So we use the symbol greater than, then we insert the name that we want to give to our file that will save our output. In my case, I will use output.txt, okay? And you click enter, and you wait for our output. We will not see the output on our terminal because when the command is running, it's saving the output on the output.txt file, okay? So in order to see the output of this command of LinEnum, you need to open the file, okay? Now, if you want to see the output on your terminal and you don't want to save the output on a file, you can take this off, okay? Now, let me just tell you that the // in this command will tell the shell to execute the script linenum.sh that is located in the current directory, okay? Now, as you can see, our scan is completed, and if you do ls, you will see that we have here our output.txt file. Now we can read our file with nano, so nano output.txt, and as you can see, we have here our output. In this output, you have information like basic system information, like OS details, among other things. You will also have security and user information, like current user and privileges. You will have also environmental information, cron jobs, file and directory permissions, service and application information, among other things, okay? You will have a lot of information. Now we have here some exercises that we can do. And now you ask me, but why do we need to answer these questions? Well, these questions will help us to get more familiar with the output, okay? So, in order to answer these questions, we need to search on the output file the answer to those questions, okay? So, we already SSH into the target machine. Now, here the first question is, what is the target's host name? Now we can search the answer to this question. Let's see. Okay, as you can see, host name, 𝒂𝒂𝒔, so that's our answer. Second question, look at the output of 𝒕𝒉𝒊𝒔. How many users are there on the system? So let's search for it. Okay, so as you can see, contents of 𝒕𝒉𝒊𝒔. Let's see how many users are there. Okay, 1, 2, 3, 4, 5, 6, 7, 8. As you can see, we have 8 users. So that's our answer. How many available shells are there on the system? So let's see. Available shells. We have 4 shells. So that's our answer. What is the name of the bash script that is set to run every 5 minutes by cron? Okay, let's search for it. We have here Crontab contents, and the name of the bash script that is set to run every 5 minutes, so as you can see, this is minutes, is @script.sh, so that's our answer. Now, what critical file has had its permissions changed to allow some users to write to it? So here we can see that here the critical file that has had its permissions changed to allow users to write to it is the @passwd. So that's our answer. And as you can see, it says, well done, bear the results of the enumeration stage in mind as we continue to exploit the system. Now that you are more familiar with the output of our scan, it's important to discuss SUID, as known as set user ID, and GUID, as known as set group ID permissions. These are special permissions in Unix-like operating systems, such as Linux, that enable users to execute a file with the permissions of the file's owner or group, respectively, rather than with the permissions of the user who is executing the file. For instance, imagine you have an executable file that you didn't create, but it has SUID permissions. This indicates that when the file is executed, it will run with the permissions of the file's owner, not the permissions of the user who initiated the execution. In this case, you. Similarly, when an executable file has GUID, it means that the file will execute with the permissions of the file's group, rather than with the permissions of the user who is executing the file. In terms of the permissions displayed for these files, the presence of S in the permission string indicates the SUID or GUID bit is set. For example, in the case of SUID, the permissions might appear as you can see here, okay? Likewise, for GUID, they might appear as this example here, okay? Now, if you are interested in further exploring Linux permissions, you can watch my video on the topic, which I'll link below and above in this video. It's important to note that while files typically have read, write and execute permissions, SUID and GUID add an extra layer of control over file execution privileges. Now, having in mind our output from LinEnum scan, you will see that we have SUID files on the system. However, we can search for SUID or GUID files manually with the following command: find /-perm-u equals s-type f2, the sign greater than, and then dev null, and you run the command. Let me just tell you that the find in this command is used to search for files and directories within a specified directory hierarchy, okay? Then the / specifies the starting point for the search. In this case, it starts the search from the root directory, which is the top level directory in a Unix-like file system. Then the --perm-u equals to s. This specifies the permissions of the files to search for. So, -perm is used to specify permissions, and u equals to s indicates that the files should have the SUID set. Then the type f specifies that the search should only consider regular files, excluding directories and other types of files. And then the rest of the command redirects error messages to the dev null, okay? A special device file that discards all data written to it. This effectively suppresses error messages from being displayed to the user. Okay, now that we know all this, let's put our knowledge in practice and let's answer all these questions, okay? So, we already ran our command, so these are the files that are SUID, and let's see what is the path of the file in user trees directory that stands out to you. As you can see from the output of our command, we only have one path that has user trees directory, and that path is the home/user tree/shell. So this file has SUID permissions, and our user 3 can access it, okay? So that's our answer. We know that shell is an SUID bit file, therefore running it will run the script as root user. Let's run it. Okay, we change of directories to this one. As you can see, we are now inside of the user 3 directory. Let's list to see. And here we have our shell. Let's run our shell and see what happens. Okay, and as you can see, we are now root. This is one way to escalate our privileges. So if you run the command whoami, you will see that you are now root. You were user 3, but because you had access to a shell that is a SUID file, it means that we are running the file like if we were the root user. And because of that, we could escalate our privileges, and now we are root, okay? However, this isn't all. We have other way that we can use to log in as root user. This other way is through our /passwd file. For instance, having in mind our output of the file LinEnum.sh, so this one here at the right side of the screen, we know that user 7 is a member of the root group, so let me just show you, okay? So, as you can see here, the root has a group ID of 0. As you can see here, group ID of 0. Now, if you go down and see the user 7, you will see that he is a member of the root group. So, as you can see here, group 0. And because of that, he can write in the /hosts file. So, if he can write in this file, he can add a new user with root permissions. Now, before we move on, we need to know why this file is so important. This file stores essential information about user accounts, information like username, password, user ID, group ID, user information, home directory, command shell information. And you can see this here in this example on /ecmi, okay? This is the username, this is the password that is represented by an X character, and the password is stored in a file called shadow. Then we have the user ID, the group ID, we have user info, we have home directory, and we have command shell, okay? So each part is divided by a colon, okay? Now, we have another exercise that will put our knowledge in practice. So, because we are user 3 and only user 7 has permission to change the contents of the 𝒕𝒊𝒔 file, we need to switch off users to the user 7. To do that, we will use the command su and the username, user 7. And now, as password, we will insert password. You can see all this here, okay? So, password. And we are now user 7. So if you run the command whoami, you will see that you are now user 7. Let me just tell you that this is vertical privilege escalation because we will get higher level permissions. We are a simple user with limited permissions and we will become root. Let me just tell you that that's the answer to the second question. And let's begin our work. So, first we need to create an hash. And to create an hash, we just need to use these commands here. Open SSL, passwd. However, we will insert as salt new. So we take this off. New. And as password 1, 2, 3. And we passed it here on our terminal, on the user 7's terminal, okay? And here we have our hash. Now we need to take this value and create a new root user account. We will use nano to edit our @passwd file, okay? And now at the end of this list, we insert our new user. So the username will be new. You just need to follow all this here. Then colon, because as you remember, all the fields are separated by a colon. Then our passwords, and if you don't remember, you can use always this list here, so you know that first goes the username, and then you use colon, then the password, then colon, then user ID, then colon, and you just need to follow this here, okay? Now we insert a colon, user ID. As you remember, the user ID is 0 because the user ID of the root is set to 0, and in this case we are trying to create a new user that has root privileges, so 0. Then group ID is 0 as well, and then we just need to copy this here because it's the same as our root, okay? And now you just need to save it. Now we just need to change of users, and in this case we are changing to the user new. It was the one that we created that will have root permissions, okay? So su new, and the password in this case is 1, 2, 3, the one that we have here. And as you can see, now we are root. As you can see, we did it. We escalated our privileges and now we are root. So the direction of our privilege escalation was vertical because we gain higher privileges. Now let's explore other way to be root by using cron tabs. Cron tabs are configuration files used to schedule tasks to run periodically on Unix-like operating systems, including Linux. We have here on 𝒕𝒊𝒔 an example of a cron tab, as you can see here. So this is an example of a cron tab. Now you can exit this here because we don't need it anymore, and you can exit as well the user 7 session, okay? Now let's read our output file and let's go to our cron tabs, okay? And here we have our cron tabs. So these are the cron jobs that are scheduled here on the system, but if you don't want for instance, run our LinEnum tool, and if you want to see what cron jobs are scheduled, you can run the command cat, then etc. Crontab, and now you can see the same that you saw on our output file, okay? Now, you saw this on user 3. However, we need to switch to user 4 because we know that the file 𝒕𝒉𝒊𝒔 is scheduled to run on the user 4's desktop, and this file is owned by root, which means that the file will run with root permissions. So now we can switch off users. So su user 4 and the password is password. You have all the information here below, okay? Now, as you can see, we are now user 4. Now we can run the command once again. And now that we know that the script will run on the user 4 desktop, we can change of directories to the desktop of user 4, okay? So we copy, we change of directories to this one, and now if you insert LinDes, you will see that the file 𝒕𝒉𝒊𝒔.sh is here. So now you ask, but what can we do with this information? What can we do with this file? How this file will give us root permissions? Well, if you run the command LNDES-L, you will see that we can write this script. So we can create a shell and paste it in this file. Now let's create our payload with 𝒕𝒉𝒊𝒔 on our machine, okay? But before, we need to see the IP of our user 4, okay? So this one here, because we will insert it on our shell. We copy, and now we can create our shell. So we will use this command here, we copy, and we go to our local machine. However, we need to change where it says local IP with the actual local IP of user 4. So with this one here, and we paste it here, and we click enter. And this is our payload, so we just need to copy this and go back to our user 4 machine, and we just need to replace the contents of the file 𝒕𝒉𝒊𝒔.sh with our payload, okay? So let's list, and here we have our file. Now to do that, we insert the command _echo, our payload between quotes, like so, then the sign greater than, and the name of our file, in this case is 𝒕𝒉𝒊𝒔.sh. We click enter. Now we need to start our netcat listener, like so, and C-LVNP, and the port we inserted on our reverse shell, okay? That is this one. So if you go here, L port, you just need to copy this number here and insert it on our netcat listener. You click enter, and now you just need to wait 5 minutes more or less, because that's the time that our file 𝒕𝒉𝒊𝒔.sh takes to run, okay? And as you can see, we have now a connection. As you can see, connection received. So let's run the command 𝒂𝒐𝒊𝒔, and we are root. And once again, we escalated our privileges, and now we are root. Okay guys, thank you for sticking with me through this exploration of privilege escalation. We've learned a lot about how access can be gained in places it shouldn't, and looked at tools like LinEnum to see this in action. Remember, the power of knowledge comes with the responsibility to use it ethically. Never use these techniques without explicit authorization, as doing so is illegal and can cause real harm to individuals and organizations. If you are interested in cybersecurity, always approach it from the perspective of strengthening security and protecting systems. Don't forget to like, subscribe, and hit that notification bell to get more updates. Until next time, stay curious, stay safe, and keep learning. Bye bye!